for our wiki, we had Graham's Law of Diffusion, and it states that the rate of diffusion of gas is inversely proportional to the square root of the gas's molar mass. This definition stays there. And the formula of Graham's Law of Diffusion would be R equals square root of molar mass of one gas over the molar mass of another gas. And for the example, I have determined the rate of diffusion of hydrogen compared to oxygen, and this is how you would solve for it. You write down the formula, which is R equals square root of molar mass 1 over molar mass 2. Plug in the numbers. R equals square root of the molar mass of oxygen, which would be 16, but since it's diatomic, you square root of the molar mass of oxygen, which would be 16, but since it's diatomic, you times it by 2, so 32, and then over the molar mass of hydrogen, which is 1.01, since it's diatomic again, it's 2.02, and right here you always put the large number on top, and that comes out with the answer of R equals 15.84. Square root is 15.84, and then for the final answer, the rate of diffusion of hydrogen compared to oxygen would be 3.98.
Diffusion is the tendency of molecules to move towards areas of lower concentration until the concentration is uniform throughout. In this example, we have a column or cylinder of bromine gas, and as time goes on, the bromine gas is sealed from the bottom and starts to spread through the top until the vapors have reached the top of the column and the substance is uniform throughout. Diffusion is the process that occurs when a gas escapes through a tiny hole in its container. A good example of diffusion rates is a blimp, because it has helium inside of the blimp, which is less dense than air, and one of the challenges of maintaining a blimp is keeping the helium from seeping out. You may have noticed that a party balloon filled with helium or air gradually deflated over time. That is because there is tiny holes or pores in the latex balloon that let helium seep out and oxygen in, making it deflate faster.
Recap. During a fusion, a gas escapes through a tiny hole in its container. Diffusion is the tendency of molecules to move towards areas of lower concentration until the concentration is uniform throughout. With fusion and diffusion, the type of particle is important. Gases of lower molar mass diffuse and effuse faster than gases of higher molar mass. Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the gas's molar mass.